It's time for the ice giants, and our first stop, Uranus. It's twice as far as our last journey, so we'll be stepping up to warp 9 for this one, which only takes 2.5 seconds. Welcome to Uranus, or Uranus, or Uranus, the solar system's butt of many jokes. Some people are embarrassed about it, but it doesn't hurt to have a little fun, and it doesn't mind. It's a planet. It's been said that Uranus is huge, and also that scientists long to probe Uranus. But joking aside, one of the reasons many people fail to learn about it is because of the humour they find in its name. A name which breaks from tradition with planet naming, and for once goes with the Greek god of the sky, not the Roman equivalent, who's called Caelus. The last 2 planets we visited are known as gas giants. Now we're in the realm of the ice giants, and Uranus is the coldest of all the planets. In the upper atmosphere, the temperatures can get down to -220 degrees C, and the wind speeds up to 900 kilometers an hour. Along with being the coldest planet, it also has the largest axial tilt. It travels around on its side. In fact, so far over, it technically rotates backwards. It's most likely that 3 or 4 billion years ago, it had a major collision with something bigger than Earth. It takes 84 years to go around the Sun, and in 2033 will only have completed its 3rd orbit since being discovered. The poles spend 42 years in constant light and 42 in constant darkness. As with all the giant planets, it has a ring system, though it's pretty faint. It reflects only 2% of light and is difficult to see. It also has moons, 27 known so far, and they're named after characters from the works of William Shakespeare and Alexander Pope. Because they're so far out in the solar system, only Voyager 2 has briefly captured them back in 1986, and we don't yet have full images of them or as much knowledge as we'd like. Let's have a quick look at the major ones. Firstly, Miranda. It's 470 kilometers across and similar in surface area to the state of Texas. It has one of the strangest and varied surfaces we've seen, though we can't see all of it. Voyager 2 managed to successfully capture about 50% of it around the South Pole, and has the biggest known cliff in the solar system at 20 kilometers high. Ariel. 35% of Ariel has been captured, well enough for what scientists term geological mapping, and it's quite a young moon, possibly formed from the debris left behind after the giant collision which put Uranus on its side. Umbriel has a really dark surface. It reflects only 16% of the light that strikes it. 40% of it has been captured, and it shows to have had a lot of impacts in its time. Titania, not to be confused with Titan, is the largest of Uranus's moons. Pictures taken show 40% of its surface, and its features have been named after characters and places from William Shakespeare's plays. There are some incredibly long valleys here, up to 1,600 kilometers long, which is the same as the moon's diameter. Oberon is almost as big as Titania, and also has 40% of it mapped. It has a slightly reddish colour, and its surface has been shaped by numerous comets and asteroids hitting it. Uranus was the first planet to be discovered with a telescope. You can't see it with the naked eye, and the ancient cultures weren't aware of it. Its orbit is the most elliptical of all the planets, meaning closer to or further away from the Sun. when it was first observed by scientists, it repeatedly didn't appear where it was supposed to. This led to the thought that yet another planet was changing its orbit. From some very clever mathematics, the position of this hypothetical planet was reckoned by a man named Urbain Le Verrier, and lo and behold, there it was. Johann Gottfried Gaul spotted it in almost the exact position it was supposed to be, and that planet is our final stop, Neptune. Neptune, brother of Jupiter, son of Saturn, and god of the sea. It's the furthest planet from the Sun, 30 times further out than the Earth, reaching a mind-boggling 4.5 billion kilometres from the centre of the solar system. It has the longest orbit, taking 165 years to go around, and is the densest giant planet. Weather patterns can be seen on its surface, and the wind speeds can reach 2,100 kilometres an hour. That's faster than the speed of sound. It gets below -200 degrees C in its outer atmosphere, but over 5,000 degrees at its centre. Unlike the gas giants Jupiter and Saturn, which are mainly hydrogen and helium, the ice giants have more water, ammonia, and methane. It's been proposed that both Neptune and Uranus could have their methane turned into carbon at their cores, which would result in hailstones made out of diamonds. Neptune has a faint, fragmented ring system and 14 known moons. They're named after Greek water deities, and most of them are tiny, but there's some peculiar activity happening out there. The giant planets normally have lots of large moons, all moving around their planet's equator, but here we see only one large moon. It's not on the equator, and it's going the wrong way. This is Triton, not to be confused with Titan around Saturn. Triton was most likely a dwarf planet which has been captured by Neptune. With its arrival, it's suspected that virtually all of the other moons were smashed into or had their orbits altered, maybe even breaking free from Neptune. There is no other example of this among the planets, and scientists are keen to learn more about it. When another mission to Neptune finally arrives, maybe even landing something on its surface and capturing more than the 40% of it we can see so far. There are now only 2 other sizable moons around Neptune. Proteus is Neptune's next biggest moon, but it's 32 times smaller than Triton. Nereid is quite possibly a moon disrupted by Triton. No pictures exist of it. We don't even know what shape it is. Its orbit is so elliptical, it's more of an oval than a circle, that comes in really close and then flings out far away. It may be the last surviving original moon after Triton's arrival, and hopefully one day we'll be able to see what it looks like. So that is all the planets and their main moons, but there's so much more out there. We haven't even talked about the asteroid belts, or Trojans, or comets, or what's outside our solar system. Of course, if you're interested, that shouldn't stop you. All of the things you've seen and heard today are freely available on the internet, plus a whole lot more. One last thing before we go though. If we look up from Earth, we can see a bright star known as Alpha Centauri. It's so bright because it's actually 3 stars. 2 of them, forming a binary star system, as close together as Uranus and the Sun are. If Jupiter had become a star, then we'd be like that. Imagine what strange orbits the planets must do around them. The other star is Proxima Centauri, and it's the closest star to our Sun. Though not that close, it's 40 trillion kilometres away. If we revisit our yoga ball and football field, and the yoga ball is now the solar system up to Neptune, then we will have to cover more than 30 football fields to get there. It's 4.25 light years away. The fastest any space vehicle has left the Earth's atmosphere is 57,600 kilometers per hour. That's almost 1 million meters every minute, 16 kilometers every second. That's very fast, and at that speed you could fly from London to New York in under 6 minutes. However, it would still take 8.5 years to get to Neptune, but to Proxima Centauri, 80,000 years. Space is big, and stuff takes ages. Thank you so much for watching this introduction to the solar system. If you enjoyed it, then the very least you can do is click the like button. Comments, questions and corrections are all welcome below.